Hi, in this Let's Create series we're creating a lights out puzzle game. In the previous episodes we created the game board and the light toggling logic. In this final episode we'll implement all the remaining levels for the level select and add a winning animation. Let's get started. In the GameManager.cs script, the first thing we're going to do is add a few extra levels. We've got our first level, which is a very easy 3 button presses. We'll add another 24. One for each tile when we select a level. After each, I've put a comment as to how many button presses you need to solve them optimally. You can see they go from small number to a large number. You don't have to implement the same ones as me, feel free to add your own levels. Sometimes lots of presses doesn't mean harder if they're generated in such a way that it's easy to see the answer. Now we've got them all, let's update the code so we can select each of them. In the toggle method, we'll set our level variable. At the end of this, after we've turned on the level light, we need to turn our row and col into an index into our levels array. Annoyingly, when I started writing this, the rows count from the bottom, but I've just created the levels in increasing difficulty, with the least button presses at the top, so we'll need to do a little conversion here. This sort of thing happens all the time in programming. You could go back and change the way the tiles are constructed, or we can just handle it here. No way is more appropriate than another. So to set the level, we need a number from 0 to 24. We'll start by taking 4 minus the row. This means that when row equals 4, which is the top row, this will be 0. Then we multiply this by 5, so the second row will start at 5, third at 10, and so on. Then we can just add on the column. This will give us our level number. Let's jump back into Unity so we can test this out. Currently, the game mode starts as none, which means we can't select anything. Let's change that to level select so we can check this out. Hitting play, we can see that when we start, we can click on the lights and we're selecting just one at a time. Let's take the middle level. This should be a 9-step solution. If any of you know how to solve these, the normal way is with a light chasing algorithm. You just click below any lit light starting at the top and working your way down. This doesn't always work. Like in this case, you end up with some lights lit on the bottom row. We can press start game again to restart the level. I know the solution to this one. You can click the first, third and fourth on the top row, then follow the same procedure, and voila, we're done. That's working great, but it's very anticlimactic when you finish and nothing happens. So let's jump back into the code to check when we win and create a nice animation. In our GameManager.cs script, we want to check if all the lights are out. The best place to do this is immediately after you've toggled a light. This is because you can only win after you've just turned off the last lights. So in our toggle method, after we've toggled the surrounding tiles, we check for the win condition. To do this, start with a boolean called lights on, which starts as false. Then we'll iterate over all the tiles like we've done before, and inside the loop we take our lights on boolean. We then use OR equals to OR it with the tile state using isLightOn. This is basically saying lights on equals lights on or is the tile light on. When you are ORing booleans together, then if you ever get a true, the result will be true. So by the time this loop finishes, that boolean will be true if we have any lights left on. We need to check the inverse of that. So if not lights on, the exclamation mark is shorthand for not. You could do lights on equals false if you prefer. Then we first want to set the game mode to none. This stops us being able to interact with the puzzle anymore. Then we want to start a coroutine with start coroutine, and let's call that show animation. And we'll create that right now. This is a coroutine rather than a standard function. This is because we're going to want to have delays in here, and the way we indicate that it's a coroutine is with the IEnumerator type. Note that I'm using Visual Studio, and it's helpfully imported system.collections for me, which is where IEnumerator lives. You may have to add this yourself. We need to define what we want our win animation to look like. We'll use the same construction as our levels to keep things consistent. So create a list that contains a tuple of 2 ints. These will be our row and column index for the lights we want lit. The win lights are going to be a smiley face like this. So we use new to set this straight away and pass the tuples that define the light pattern. Again, feel free to use any pattern you like here. Just like setting the level, we use a for each loop to iterate over this, and simply call setState with true on each tile to turn the light on. All the other lights will be off, as we've just completed the level by turning them off. We want to display this for a second before turning it off. To do this, we yield return a new wait for seconds, passing in 1, which means we'll wait for 1 second before continuing on with this coroutine. After our second, we want to turn all the lights off again, iterate over rows and cols like we've done many times now, and just set state to false. So that will have flashed our smiley face winning animation for a second, and then turned it off. To make this more obvious, we should flash it 3 times. After turning off the lights, we should wait for 1 more second before we do anything else, then we flash it again. Rather than copying and pasting the whole code 3 times, we can just wrap this in a for loop for I going from 0 to less than 3, so it'll happen 3 times. That means this animation will take 6 seconds. Finally, after we've finished, we set the game mode back to level select so the user can pick the next level to play. Let's check this out back in Unity. Let's choose another level, bottom left. Ooh, this is interesting. When you've light chased this down, we've got those 2 lights lit. I happen to know this means that you need to hit the first 3 squares on the top. So let's restart this, complete the level optimally. And there we have it, the lovely flashing smiley face at the end. Then we can pick a level and go again. As usual with the Let's Create series, I've helped you create the core game mechanic, and I leave the iteration and polish up to you. There are several improvements you may want to make at this point. You could disable the start button if you haven't selected a level yet, extra buttons for restart level or back to level select, add sound on button presses and the winning animation, unlock levels only when completed the former ones, add scoring. The original game only let you complete a level if you did it within so many presses of the optimal solution. This is a big topic in itself, working out the optimal solution, which I thought was way too much for this series. There are loads of resources out there on this, so feel free to go have a look for it yourself. I hope you found this tutorial useful in some way. As ever, the full code is available on GitHub, and I put a link in the description below. See you next time.